I'm sorry. Who is Missy TV?
I tried to change that my name, but I don't know what it was
Who
supposed
is
to be.
this?
This Ariana Richardson.
Okay, you got to change that soon because they have a policy with that.
I
So
know me and the other teacher was trying to do it. It
okay,
said I did it, but I don't know why it's keep popping up.
okay, no, that's cool. You're here because I reached out to you I think yesterday or something, but you're here, so that's good. You do have to
Okay.
keep your camera on the entire time, and that's for
Okay.
all students. CPS policy, not mine. We have 10 more minutes before we start, so you want to make sure you're in the camera. I'm looking at the ceiling, Miss Richardson. Need to see you in the
Okay.
camera, and that also goes to Mr. Champagne. If I have to actually do it more than 3 times, I'm gonna have to eject you from the room because that's failure to comply. Okay, so just keep that in mind. Put 10 minutes, no, not 10 minutes, 9 minutes. So I'm trying to give people time to get into the classroom. You should be trying to start a Google Doc like I've done, and then we're gonna go into the norms and the problem in 8 minutes. Who just came in the room? Can't see them yet. Okay, that's Daje. That's who is coming in the room. All right. And who is this next? So while we're waiting, you should be setting up your screens. In 8 minutes, I'm gonna do a camera check on everybody. Thank you, Daje. Thank you, Lisa. And Miss Richardson, Mr. Champagne. This is your second warning. You need to turn on your camera, sir. All right, let's take some notes. It's 12:23 p.m. Champagne. All right, so I'm gonna do attendance real quick. I'm gonna check on Champagne one more time before I have to have him removed. All right, so 7 minutes. Okay, attendance. Let's see here. Let's do a quick survey. All right, so Lisa Brown is here. Carter is not here. Mr. Champagne, you need to turn on your camera, sir. All right. Mr. Champagne is absent. Khalil Connor, absent. Roy Mine Davis, absent. Sharon Franklin, absent. Sinclair Lightu, absent at the moment. Gabriel Mayweather, he's absent. I don't see him. Let me take care of this. All right. Gabriel Mayweather, that's why he was absent. Yeah. Daje Moore, present. Joel Moreno, not present yet. Okay, let's see what's going on. Let's see here. Porter is absent. Christian Puentes is absent. Miss Richardson is here. Melody Terry absent. Okay, that's Joel. He just made it. Okay, all right. Present. Let's see, where was I? Melody Terry. Did I get her? I don't see her, so she's absent. Jamil Tyler is absent. Alexis Valdez is absent, and Mr. Wallace is absent. All right, let me refresh these screens. While you're in class, your camera has to be on. I just had to remove one student already. So please, 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 let's just make this easier on ourselves, okay? Who's this? This is Miss Franklin. Okay.
Miss Tyler.
Yes, ma'am.
I'm getting ready to go see my caseworker, and I was gonna get on my phone while I'm on my way over there in school, and my camera not gonna work on my phone.
Okay, well, thanks for letting me know, but you gotta at least try to participate. Like you're en route there.
No, I'm finna leave out right now, but I wanted to join class and let you know before I leave.
Okay, well, just try to review the video and get everything done. I'll give you till tomorrow is the best I can do, dear. All right.
Okay.
All right. So that's Miss Franklin. Let me go back. Make a note here for her. Okay, I think I got everybody. Let's check one more time. Joel, Dajay. Yeah, I think that's everybody. Richardson's here. Okay, so see, Terry's gonna come later. I know she usually comes. And Carter. All right, let me save this. Okay, so right now you should be seeing my screen and you should be setting up your screens the way I have. And the way you want to, the reason you want to do that is because you want to be able to type in the notes, like the question today, and you gotta be in Edsby. So this is what I mean by set up the way I have. There go Lee Carter. I knew it. He usually comes just a little bit before the clock is over. I just seen Lee Carter. There he is. It said Lee Carter is coming. Okay, Mr. Carter, welcome to class. Let me see here. Make sure you note that he's here. Okay, who is this coming? I think that was Gabriel. Yeah. Okay, welcome, Gabe. Again, gotta repeat this for you guys. Student just got ejected a moment ago. You gotta keep your cameras on. Okay, it affects your attendance because we have to make sure you're participating in class for one, and two, you are you. And we got some things going on where people are not them. So just keep your cameras on the entire period and try to respond when I'm asking you a question. This is called demonstration. If I'm calling on you, it's not to put you out there. It's to make sure you get points that help you towards the beginning of the coursework. You might have a 0, and some of these points that we gain through class might turn a 0 to 50. So if you go back and look at some of your scores, you guys, you'll see there's some scores that change to just 50 out of 0. Doesn't mean you did great, but you did great in class or in actual virtual class. So you have participation points and demonstration points as well. All right. How much time we have left here? It's about 2 more minutes if everybody's considered late. Um, use this time to set up your screens. And again, I've already started the document off. You want to be logged into Edsby. You also logged into whichever Google account you're going to use for typing this document up. All right. And we're going to be using, I think it's available on cell phone too, for you cell phone people. We're going to use a simulation of what's happening in this problem. So get your screens ready because you have to run 2 screens. We're going to take a screenshot of our simulation and we're going to put it into our Google Doc. So I think yesterday we was making drawings through Google. Now we're going to take snapshots and put them in after we make certain simulations. Okay. So a minute left. Let me just get this. Where's my 5 basic? There you go. That ready. I'm going to call them back. All right, let's get into it. So let me get my list going. Who's in the room again? All right, cool. So let's start at the very beginning. Daje, you're first in the list. Can you read off number one? Let me
No
open
one
this.
has the right to hurt another person.
Thank you, Daje. Gabriel, number two. Gabe, you gotta unmute yourself.
Education in the classroom is sacred.
Thank you, sir. Number three, Mr. Moreno, can you read that?
Um, yeah, we will never behave in a way that will discredit ourselves, our school, or our families.
Awesome, sir. Let's see here. Who's next in the list? Scroll down. Lee Carter, can you read number four? Is he there?
Excel Academy Southwest student is always a lady or a gentleman.
Thank you, sir. Lisa Brown, can you read number five?
We take part in the Cell Academy in Southwest.
Okay. Next on the list is our academic norms, same standards. Miss Richardson, can you read number one?
We respect the opinions of others.
Thank you. Going back to the top, Miss Moore, can you read number two?
We respect the culture of the classroom.
Thank you. Mr. Mayweathers, can you read number three?
We attentive and participate.
Thank you, sir. Joelle, can you read number four?
We have high expectations of ourselves, our peers, and our teachers.
Thank you, sir. Who's next? Got Joelle. Lee Carter, number.
We are here to focus on preparing ourselves for post-secondary identity.
Thank you, sir. Thank you. Right on point. All right, so let's get into today's assignment, right? You should have already logged into Edsby. All right, and I try to make sure the link is ready for you guys when you want to come into the room. So it's always going to be at the top of the day. That's the last thing I post. I want you to be seeing that and get in the room. But next, we got to get into today's agenda. So it's going to be some parts that we have to read out loud to the class. And again, these points help you later on. So if I call on you, don't be shy. Just read it. That's all you got to do. And you get the points. Okay. And let's see who hasn't had a turn. Lisa, can you start us off with today's introduction, I guess?
Yeah.
Thank you.
Hello, all future electrical engineers. Asynchronous problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well.
Okay, thank you, Lisa. And then the other part to this, and I'm just pulling this from Edsby because, I want to make sure it's covered and you have an idea of today's objectives. So the next part is this, and can I get Miss Richardson? She's a new arrival. Can you read that in the chat?
Yeah. Wait, which one?
So start with please remember and go down.
Please remember to give maximum credits all calculation steps for the final answer to the
Synchronous?
in the
Synchronous?
problems need to be uploaded to SC via the same format that we have been using since the start of the quarter. This format is shown in the video. Type Google Doc, convert it to the PDF. Stay safe out. Stay safe out there. What?
And Zen. Okay. It means peace, dear. All right. She said, what? All right. So moving back to this, right? And you got about 15 points towards, some scores of the past for that. But let's discuss today's problem so we can get it over with. And then we can go over again. And I'm doing this. If you know how to do it, just bear with me. But we have a new student, so we got to go through it again, how to submit assignments to Edsby. So we'll do that after we get most of it done. But first, does everybody have this document started? So if you're not sure how I did that, let me go back through the steps. So you click on a new tab, make sure you're signed into some form of Google and you log in to your profile. All right. Next, you want to make sure you click on the Google Apps icon here and come to Docs. Once you're in Docs and you're logged in as one of your Gmail accounts, you can click on blank and create a Google document. This is the fastest way to do it because if you type Google Docs and then you try to go through the procedure, it might get, certain things might get confusing because it was all over the place now. The next thing I did is I labeled my document. You can do that by double clicking on the document right where you see the title, and you got to name the document. This is different from the header and the title, right? So we named it for today, due now, 22nd 9 2020. That's for today's date. And it's always the date we're going to use for our documents in class. But the only thing that changes with this title of the document is the dates. The next thing is the header. For every assignment, you will type a header. This gets you into formal writing of research papers. So it's only going to include your first and last name or full name, not my name, but yours. You're going to type that there. And then the next thing you're going to type is the date again, and then what period and subject matter you're in. So this has to be in there, and yes, points will be taken off if that's not visible. Next, we have the title. Now, where did I get the title from? Was there a question? Oh, that's just background noise. All right, so where did I get the title from? Well, if you come in Edsby, you should have access, because all of you guys got here. You would see that I labeled it due now, force field, and the concept you're learning is electric force. So usually in brackets, as an exit slip, the terms in the class will be in brackets. And if you can give a definition of what's in brackets, you'll get more points towards your report. Now, let's move on. Everything all right, Miss Richardson? Oh, you gotta mute yourself. You got some weird discussion going on, dear.
Yeah, can you mute your mic?
Okay, there you go. All right, so let's carry on now because you gotta follow along. There's a lot to do. Now, the next thing, and thanks for the support, Ms. Richardson. I'm sorry, Mr. Rush. The next thing you want to do is take the problem, and we're going to discuss the problem in one moment. So we're going to come to Edsby, and we'll grab this problem, right? This is problem 1S. Now, you got two to do. One's called synchronous, the other's called asynchronous. Let's put this here. All right, and let's see here. Miss Moore, can you read 1S, the problem in the chat? Do you see it?
In a certain region of space, a uniform electric field has a magnetic of 4.60 times 10 to the fourth power newtons per
Coulomb.
coulombs and points in the positive x direction. Find the magnitude and the direction of the force this field exerts on a charge of A plus 2.80 microcoulombs and B negative 9.30 microcoulombs.
That's awesome. Thank you. Thank you. So take a moment, everybody. You should be copying this problem over to your Google Doc right now, right? When nobody's saying go back up, I don't know where to go. This is also in Edsby. So this is just me making sure you're paying attention, because in a couple of minutes, I'm going to ask you to share your screen. You should have typed up as much as I've done if you were paying attention. If you're not, it's going to be difficult on you. Please, please pay attention in class. Okay, and then I'm gonna center this. So you should have done what I've done. You have this much typed up at least. So there's two parts to this. And don't forget to grab the second part, which is in Edsby. That's the second question. This is your homework problem or asynchronous problem. So I'm gonna put that in there too, so we don't forget about it when you're trying to submit all your work. If you look, the questions are almost identical. The only thing that changes is the number values. And I'm gonna show you how to calculate this problem. And all you have to do is later on today, figure out how to use the same techniques to do the second problem. That's all you gotta do. So let's keep going because we still gotta get our simulations going, right? A little space in between that because we're gonna put something there. But we gotta talk about something known as charges and electric fields and forces. Somebody else is coming in the room. Trying to see who it is. Oh, Melody has arrived. Okay, let me go back and do attendance real quick before I forget. Hello, Melody. Leave your camera on the whole time, dear. Glad you made it. All right. Melody's made it. Okay, make sure it saves. It didn't like it was saved. Last thing I need to do is go back and like it didn't say. There we go. Nobody being like, you didn't put my attendance in right, Mr. Tyler. All right. So where was I? We're at this point, Melody. Hopefully you can catch up, and you always get access to the video. But now, and you made it on time because we're about to do a simulation actually. So the simulation, we got to talk about a few things. Let's type it out. And the first thing we want to discuss is what is it? 12. How am I doing on time? 12:41. We got 1:20, so I got to move quickly. But first thing we want to talk about is the definitions of such. So we have something called electric field. And it has a certain magnitude, right? And we'll call that E in our equation. It's going to be equal to a force on a certain positive charge. So I'm going to show you the simulation and what this means, but just take these notes so you can have them as we go through the problem. So F, and you can treat it as a Newton, right? Because we talked about forces, is going to be basically force on positive charge, okay? Now that's all one unit by itself. It's going to be divided by, come over here, divided by, so it's a ratio, and then you're going to have the amount of charge. We call this Q naught. Looks like Q.
Mr. Tyler, can you make your screen bigger or something a little bit?
Make it bigger? Okay, hold on. Does that help any?
Yeah, you just gotta scroll down. Yeah.
Okay. So Q naught is, put this in parentheses, written as this in math. So it's a lowercase q, but naught is like the zero. There we go, 0. And you actually highlight the 0 and you subscript that. I'm going to text and do this. And that's how it actually looks in math books. So amount of charge is what Q naught is. All right. Now we got that much information. Now we got to talk about something else known as the electric force. Now electric force, because you need to figure out electric force if you're not given that F above, is the force and the charge, is so force is basically written as F still, but as a vector, say vector F. But it is equal to the same Q naught. So come here and grab that. And Q naught is a constant, so it's always given, by the way. So take this, is equal to this, just multiply it by your electric force. Now all I did is a little bit of algebra there. So if you're not sure what I did, I just gave you I gave you two things, but there's steps in between, if I can say it that way. I'm doing that because we have a simulation to do, and I can always explain that, changing around of that. But we're not really doing too much of that in the problem. We're just straightforward answering the question and what we're about to work on. So we're given the right equation in the second one. And you're going to need that later on. But I'm letting you know there's other problems that you'll see where you got to do some algebra to do what I just did there in those two steps. All right, so let's center this. This is your notes. And now we got to do the simulation part. So I'm going to put a link in the chat, and I'm also show on the screen what that link looks like. And you have to follow along and make the same thing work for your screen. So let's go here, because you're going to have to put a snapshot of that simulation in to your Google Doc. So I'm not going to waste time on seeing who did it and sharing screens like I did last period. I'm just going to see who did the work. You're going to need that snapshot of what we're about to do. So in the chat, there is a link. You have to click on that link right now, and your screen should look like mine's right now. So I'm going to give you about 2 minutes, and then I'm going to start moving forward with what we're supposed to do with this screen. Click on the link in the chat, open it up, and then get ready to use it in the way that I'm using it on my screen. I'm going to show you how to take a snapshot of these charges in our electric field and how to put it into our Google Doc. But you got to be following along. Does everybody click that link yet? You're going to need it in a moment. It's part of the assignment inside of Google Doc. So the animation that should come up is called charges and fields. All right. Okay, so we're coming up on a participation point moment, but it'll be after you do what I do. I'm assuming everybody has a screen open, right? Don't want to get too far and then be like, Miss Tyler, what am I doing? It's gonna mean you wasn't paying attention to me when I said have this screen up. So click on the link in the chat. 40 seconds. All right, let me just stop it and get going because I'm got the clock. So basically, these are point charges, like we talked about in our problem, right? They are in a field that you can't see. So if you take two charges, one negative, one positive, like in our problem, and you come up here to electric field and click on that, you'll see the actual electric field around the charges. Okay. What I want you to do is to grab it, either positive or negative, and bring it close, and then examine exactly how they operate when they're next to each other. All right. Get really, really good with that observation. What happens when you bring these two charges together? Now, what you have to draw or sketch is at least two sections of point charges. So you need four altogether, one negative here, one positive here. And then you need a sensor to determine where the charge will go. So if you see, if I bring it over to the blue or the negative, it changes the direction. And the sensor is placed in reference to the charge. So you get to understand, if I leave it here, you can see it's smaller. The closer I get, it gets longer. So I want you to put two sensors, one on this region for that electric field that has two point charges. And then I want you to put one over here. And you got to place it correctly so you can make it look exactly like mine. And also, you have to turn on not the direction only, but the grid, the voltage, because this is how it looks when it's actually electrified. And the values, it shows how many volts each are.
What you do to make it light up?
What did I do? What, Gabe? Gabe, I couldn't hear you, man. You said it real quick.
Make it light up. What you do?
Let's go back to, again, the settings you got to have before we take this snapshot, right? Electric field, right? Voltage, which is what you're probably looking for, Gabe. These are electrified. You saw what I did? And then values, because we got to see how many volts these charges, point charges are. These sensors are here because it tells you how much voltage is in that electric field. Now, you guys got refrigerators, air conditioners. They have induction systems that work off of this principle. Now, you guys being in this robotics engineering course, kind of know about this stuff. The last thing I want is the grid, so you can actually map it out like scientists do, and then take a picture. Now, before you take the picture, and I'm going to show you how to take the picture, you got to take this measurement device and just measure at least one of these values. Okay? So, and it tells what the equipotential is. Hint, hint, turn coming up, right? So, let me move this out the way and show you now how to take a screenshot and put it into your Google Docs so we can finish this problem off today, because we're at 12:50. Man, time flies. And we got about 30 minutes left. We still got to show the steps to solve the problem. You guys got to take this snapshot and put it in Google. So pay attention. This is how you do it. I don't want you getting lost. Once you have everything set up like I have on this screen, the next thing you're going to do is, you see these three bars in the corner? You're going to click on that, and you're going to go straight to screenshot. It's easy on this one. I found that for you, guys, just in case. We had print screen, get this print screen button, but that gave some people headaches. So I found this one, and you can just hit screenshot like I'm doing. When you click on screenshot, it looks like it didn't do nothing. But if you come in the corner You can see my screen. It downloaded something. It's a PNG file. All right, that's cool. That's all I needed, right? Now I'm going to come to my Google Doc, and this is the part where I put my simulation into my document. This is vital for your do now, right? You got to have this image in there, or it's going to be 20 points knocked off automatically. And that's going to be because you guys, I thought, were paying attention, but we'll see what happens when people put their papers in. So now all I do, go ahead.
What if the numbers don't match? Because I got it set up like yours, but the numbers
They
don't.
don't have. They don't have to.
I was gonna say I got mine set up exactly how yours, and my numbers not matching.
Okay. So again, guys, this is, I said, get it as close to what I have. I didn't say exactly, but you got to have what? The basics. Let me go back to that image. I knew they was getting frustrated. You don't have to have this this measurement device here. It's equal potential device exactly here. You can have it somewhere right here. As long as you have all of these elements, two sensors, a positive, both two positive particles, two negative particles, and then make sure it's electrified. So everything, all these settings got to be selected. You could have the ruler out here. It wouldn't bother me. As long as you have everything else, I'm fine with that. Okay. And then you got to go here and make sure you take your snapshot. Once you take your snapshot, it should download a file. And I was about to show you guys how to put that file into your Google document. So when you come back to it, y'all trying to be perfectionists. So all I'm gonna do is click on insert, and I'm gonna go to image. When I go to image, this is gonna be helpful for you guys. I was teaching this to computer science.
Mr. Tyler?
What?
What did you just say go to?
So I'm gonna do it again. I come back to my. Did you save your screenshot?
Yeah.
Okay. So what you want to do now is go to, like I said, insert in your Google Doc. You back in your Google Doc now?
Can I go to the bathroom?
Who's that?
Melody.
Melody? Yeah, come right back there. So insert, right? Image, then upload from your computer. Okay. We click on upload from computer, and it should open a menu up for you to find the file you want to use, like this one. So this is changes field, and it says screenshot. This is the one I did it twice. So this is the one I want. I'm gonna say open. It should be there, just like my screen. So you need that part in there because that's like 20%. The problem is real quick to do, and I'm gonna walk you right through it because it's 12:53, and I really want to leave you a little time to get ready for your next period. So is everybody okay with this? Is this much you should have done? Okay. And if you want to move it around easier, like I told others class, make sure you click on wrap text. This allows you to move the text around, move the image around without bothering what you typed up too much, because it's going to move the text around the image. All right. So the problem, right? Well, what do we need from this problem? Well, I gave you some equations earlier, but the second part, which was the equation we're going to use to calculate everything. And I got that from just doing mere algebra. In fact, it's not divided by right there. My apologies, everybody. It's multiplied. There we go. Yeah. So let's continue on. We're going to take this second one here. I'll keep scrolling down on me. And we're gonna use that equation the most. It's the same equation, but it's just rearranged for what you're looking for. And in our question, it asks us for the force. Let's go back to the chat. It says in that question right there, find the magnitude and direction of the force, right? This field exerts on the charge. So the first charge is 2.8 microcoulombs. All right. So let's continue on. We got first write our known and unknowns. We got this equation here we're going to use, and I'll put it to use in a moment. But what are our known values? So what do we know? And then I got to move this over. And then the other aspect is, what are our unknown values? What don't we know? Okay, well, we know that the magnitude of the electric force is given to us already, right? And that's the number they gave us in part A. But what is actually E equal to? And when I'm talking about E, I'm talking about here in the electric field. Right here. Let's go back up to the question. So it says the electric field, remember I told you electric field was E if you forgot. and come to the problem so you can pick it apart. It says it's 4.6 times 10 to the fourth newtons per coulomb. So I'm going to take this and come down here to our known values. That's our E field, or how strong it is. That's basically, guys, the arrows you saw going everywhere. It's your E fields. So I'm going to put that here, and I got to shrink that down. Electric field. I'm just going to put E. Oh, and that's Newton per coulombs, but I'm not going to put that raised, that caret 4. I'm going to put raised to the power of 4. So I'm going to raise it by going to text and doing this. So it looks better. Now it looks like an actual math problem. Cool. Now that's one value. What else are we given here? So we scroll up, we have two charges to be concerned with, right? In part A, we have basically, where is it at? Find the magnitude direction of the field exerts at 2.8 microcoulombs, right? So what does that change to? Because we want to use not micro, but what the actual number is. When you say micro, there's a new character you guys got to get used to, because we do Greek letters in math at the high level math, especially engineering and physics. So what is that going to be? We said that our Q, remember Q naught, we got to grab that from up here. And we're going to put that in our known values. Oh, you're supposed to be over there, buddy. There we go. Uh-oh, that's not what I wanted. There we go. It worked with me, but it still made my equal sign.
How you do that, Mr. Tyler?
Do what?
I don't get that. That's a 0 or something.
Yeah. So let me show you that again. So I'm actually fixing it. I actually messed it up there. Hold on. So you got to go to format and go to one of these two. There we go. And this 0, all I did is I put a 0 by it. So if I delete it and I put the 0 here, it's going to be small, but I don't want that. I want you to see how to do it. So let me go to what I did. There we go. And if I put 0 here, I think that was more talking. You basically, you put the 0 there and then highlight it, what you just typed, go to format, and you're going to subscript it like that. That's all I did. Okay. So, so the next part is, what is our Q naught? The Q naught is at 2.8 in our part A, 2.80 microcoulombs. So 2.80, and then micro is what? Now remember, that's going to be some power of 10. But to use micro, you have to actually use the character micro before you convert it, so you know what it means. So I'm going to insert, again, special characters. And in there, special characters, make sure you select math. So when I select math, it has all sorts of math characters, but I want the character for actually what? It's a micro, so M-I-C-R-O. And there it is, I see it. So that's for micro. I clicked it too many times, but you get the gist. So when I say a microcoulomb in the earlier problem, I'm talking about this here, this symbol, microcoulombs. All right. But what does that mean, as students would say? Well, a micro, let me just copy this and put this down one. And this is basically all part A's information. So part A, so you know where that's coming from. And then you still got to go back and do part B on your own and the second problem as a homework problem, because I want you to have practice before you do it again. As like it's the same process, but y'all get in the habit of trying it, it won't be hard to you. So let me 1 second, close the window. Got a fire truck going by. Sorry. Okay, so
Mr. Tyler.
Yeah.
You finna be mad.
Why?
Oh, I forget how to do it again.
Do what?
We
doing good on time, so I'm not gonna be mad, dear. It's like 20 minutes of class left. What's wrong?
How you do the 0 again?
Oh, how to subscript, right?
Yeah.
So if I come here, Daje, highlight. Let me just do it like 1 down. so I don't have to rewrite it. So you just type Q, then the number 0. Then I'm going to highlight it by holding Shift, and you can use your mouse if you have one. You highlight what you want to change. So after it's highlighted like that, I come up to Format, Text, and Subscript. Now you press the over key once because it's still going to be Subscript, and deselect it, and then turn off the Subscript by going right back to it. So that way, when you type, it types normal. Okay?
Yeah.
All right. So that answers that question. Let's finish this problem off because there's not much more to it. We're just going to use the equation above. And in this equation, we were looking for, in this problem set, we were looking for the force. So that's our force vector. Vector of force. That we call F from the above equation. And that's equal to some number measured in, you guess what it might be? Newtons. All right. Let's begin calculating. We're going to take this equation and copy that and bring it down. That here. Move it over because I got some steps to go through to get it right. But oh, I almost forgot. Ndaje threw me off. This micro changes to 10 times 10 to the -6. That's what that is. You asked me that question, I got thrown off. So you can remove micro, but inside of micro, I just wanted to let that be known because I almost forgot about it. This is raised to the -6. There we go. All right, got back on track. Okay, make sure y'all got that step there because I almost forgot about it. Micro means times 10 to the -6. Okay, so we got that part done. Now we got to start putting this stuff into the equation to get force and get the problem over with. So for the sake of time, we're just going to write it shorthand as what the equation is. Down one, and it's going to be E for electric field is multiplied by the amount of charge, which is our Q naught, and this is the vector or F, electric force. Okay, the equation is in its mathematical form, and now it's time for us to actually start putting numbers in there to calculate what force is. So what does that look like? Well, we take the known values. We know our magnitude of electric force, which is this here, this Newton per Coulomb. So I'm going to copy that, put this inside of E. I'm going to clean this up because you can just write, I think it's written as capital N and then lowercase c, if I'm right. Yeah, well, they both capital. So N/C, excuse me, for Newton coulombs. And also, don't forget about this part, is your Q naught. And that goes inside of here. So in part B, when you work out it on your own, pretty much the only thing that doesn't change is the magnitude in most cases, because that's a constant. They give you that off the cuff, and it's called the electrostatic constant. So let me put that here so you always know when you go to the problems, E is the only thing you do know correctly in here. And the electrostatic constant. And stays consistent in part A and B when you do it. So don't get confused. And if you be like, I got confused, I don't know what it, don't, it doesn't change. So put that in your notes in case it comes up again, and it will, because we got one more thing to do on electricity before we start working on the circuits. All right, so I think we're ready to calculate everything, right? What cancels out here? Remember, this is a Newton per Coulomb, NC. So let me write that out again. Newton per Coulomb. And what does that mean for us? Well, if we take it down one more step, we got to understand that we got to cancel out some things now. There's a Coulomb here and there's a Coulomb on the bottom. So therefore, when they're multiplied, we have a fraction that cancels each other out. So Coulombs cancel out and leave just Newtons. And that's what we wanted earlier from the unknowns. So strike that out. And then Coulombs down here goes away as well. So the new equation is going to be based on the calculation and what's not struck out. All right, so I'll take this one more time and just clean the equation up. We don't have coulombs anymore, right? That's gone. And all we got is a Newton here. That's on the outside because coulombs are gone here, and we just have numbers we got to combine now. Okay, so let's put it into our calculator and get this, completed correctly. One for this, since you got a lot of 10 to the powers and stuff that I would use, is not Google. I would use Symbolab here, to be honest with you. So Symbolab or any other, online calculator tool would help you. So I'm gonna put this in the chat so you can take use of this for your other problems. And you're not overwhelmed from the calculations you got to make. Ms. Terry, did you get back from the bathroom yet? I see her. Yes, ma'am. Thank you.
Yeah.
I see you. I just had to check the cameras. All right. So Symbolab, I put it in the chat. You're going to need it to calculate some things. You might want to bookmark that because you got an asynchronous problem. That's the same as this, just different numbers. And a part B problem, you got to try on your own before we leave. Right. I mean, not before we leave, but as we leave, you should try that and then knock out the other problem. So, and let's knock the problem out because knock this problem out because we got 3 more minutes, and then I'm going to try to get you guys out of here so you have a 10-minute release for your next period. Because it starts at 1:20 exactly, yeah. So there's no in between for you guys. So that, how we type this in? Let's type it in real quick. It's let me scroll over. It's going to be, let's see, I'm going to do it like this: parentheses 2.8 and 0 multiplied by 10. Here and raise it to a power, and it's -6, right? Because it's micro. I'm come over a few, multiply by parentheses 4.60 times 10. I'm going to raise it to a power, and that is also going to be 4. Okay, so I think that's everything right there. And I hit enter. Should give me an accurate answer of about, it's a decimal value of 0.12 or 13. So 0.13. Where's the Google Doc? Here it is. So the force is actually going to be, because it's so small, 0.13 newtons. That's the part A I did with you. Now you got to go back and do the same thing for part B in this problem. And what am I looking at? Oh, I'm almost good. 2 more minutes. Let me blow this up so you can see it. And that's the first part, right? Because you got a part B in there, right? And your part B, you got to do everything I just did, but you got a negative 90 or 9.3 microcoulombs. So you got to have, all of this ready to submit on Edsby by 8 p.m. tonight. And that means also finishing the asynchronous homework problem by tonight as well. So let me finish this up so I can get you guys out of here. How do you send this to Mr. Tyler? Now, some of you guys have been emailing me things and sharing documents. It doesn't always work that way, and there's a reason why I have you do it the way I have you doing it. You're going to download it as a PDF. You click on File, you come to Download, and then once you come to download, you hit PDF. The reason you do this is because if you hit the share button and send me that link, I might not be able to send it. I might be emailing you back talking about I need access. So please download it as a PDF. Once you do that, just download this and show you the procedure. You hit PDF, it goes into the download queue. I was waiting on that. There it goes. And next, you come to Edsby, which is right here, if you have it open already, the one-stop shop. And you see this icon here? Browse your computer. You click on that, find the download section. That's probably where your file went. Click on your PDF and put it into the assignment so I can see it in my grade book. If you don't do it this way, the grades will come up as green or yellow. Green means on time, meaning you got it in before 8 p.m. Yellow meaning it's late and it automatically has 20% knocked off. All right, so the videos will be ready later. I want to say around 4. Use this to get the work done because we're in week 3, and I think it's only 8 weeks in a quarter. So please, please, please try to finish strong and get all this work in. Is there any questions for me before I move to have you guys dismissed? Okay, now I'm just gonna go through and do a camera check. Looks like everybody's here. Lisa gave me the thumbs up. Okay. I see everybody. Some people, y'all gotta get better because we have to see your faces to know that you're participating in class. Right now, we're looking at people's top of the heads. And we want to work on that. But I think that's it. It's 10. It's 1:10. You guys need about 10 minutes for your next class. You're free to go and get ready. Just be ready for your next period and be there. Take care.
If y'all don't got no questions, Gabe or Joel, y'all can leave.
Oh, somebody coming back in. Gabe? Oh, no.
Joel.
Sinkyra. Oh. Hey, Sinkyra, you came to the end of class. You good?
Yes, I was having trouble.
Like, what type of trouble?
I had forgot my computer somewhere, and I gotta wait till that person get out for work. So I was having trouble with logging in, so I had to delete the Edsby app and download it back. So
Oh, okay. You on a computer now, though?
no, I'm on the phone, so I'm gonna complete the work from yesterday and today work. Today.
Okay. Just check out the video, Sinkyra. I'm pretty sure you know how to get it done. So.
Okay.
All right. Sinkyra, you free to go. We're at the end of class, dear.
Yes, I can't miss your class because I'm already behind the light, so I had to make.
It's okay. It's okay. I understand. You're a new parent, so I'm trying to work with you. But you came.
She just want to hang with us, Mr. Tyler.
I see. She's want to hang out. So, Sinkyra, I'm glad you did that, Rush. Sinkyra, while you're on the line, make sure you take this link down to the simulation we did in class, so you can do it later on your own.
Okay.
So I'm putting it in the chat, but somehow save it to your notes or whatever, or hit me up on Edsby. Hit me up. Contact me on Edsby, and I'll give you the link again, as well as Symbolab if you need it. All right. So I'm gonna stop this video.
I'm making this townhouse slide.